Hi, this is Dr. N. Sreelekha, Professor in Physics, Siddhartha Institute of Science and Technology, Puttur. So today my concept is semiconductors. So in semiconductors plays a vital role in the universe. So semiconductors are electronic devices enabling advances in communications, computing, healthcare, military systems, transportation, clean energy, and everywhere we are using semiconductors. So without semiconductors, we can't imagine the universe nowadays. So the concepts included in semiconductors are intrinsic semiconductor formation, energy band structure, extrinsic semiconductor formation, energy band structure of extrinsic semiconductors. So these are the concepts I am going to explain. So first one, semiconductors. Semiconductors are some materials which are having electrical conductivity in between conductors and insulators. So the electrical conductivity of semiconductor is very much affected not only with temperature but also with suitable addition of impurities. So in semiconductors, with the increase of temperature, the conductivity increases and hence resistivity decreases so that it has negative temperature coefficient of resistance than in conductors. At absolute zero temperature, semiconductors acts like as insulators. So the best example for semiconductors are germanium and silicon. So these are very abundant in nature. Intrinsic semiconductors. So intrinsic semiconductors are the pure form of the semiconductors. So without doping means undoped semiconductors are intrinsic semiconductors. So means elemental semiconductors. So we are not dope any other element to the pure form of semiconductor. So that is intrinsic semiconductor. So extrinsic how the intrinsic semiconductors are formed. This is the bonding structure of intrinsic semiconductor. So in this bonding structure of intrinsic semiconductor, so let us consider silicon. Silicon has 4 valency electrons and germanium also it has 4 valency electrons. So this belongs to the fourth group element. So it has 4 valency electrons. So here silicon is, it has 4 valency electrons and the silicon has 4 valency electrons and the silicon has 4 valence electrons. Like that, the 4 valency electrons of the silicon are strongly bonded with the neighboring silicon atoms. 4 valency of the silicons are strongly bonded with the neighboring silicon atoms at zero temperature. So if you can raise the temperature, the covalent bond can able to break. So here the 4 valency electrons of the silicon are strongly form a covalent bond with the neighboring silicon atoms. If we can raise the temperature, that covalent bond will be able to broken, then electron will become free. So if one electron will become free, then one hole is created respected to that electron. So if number of electrons will become free, that much number of holes are created. So electrons are occupied at a 0 Kelvin. Actually, electrons are exist in the valency band, and uh, if we can raise the temperature, see this band energy band diagram. If you can raise the temperature, electrons are trying to move from valency band to conduction band if you can raise the temperature. So in this intrinsic semiconductor, the Fermi level is lies at the middle of the valency band and conduction band like this. This is the Fermi level, for example. So this Fermi level is lies EF. Fermi level is EF. This is lies at the middle of valency band and conduction band. Because of in intrinsic semiconductor, the number of electrons in conduction band is equal to number of holes in valency band. Because of a number of covalent bonds are broken, that much number of electrons are created, that much number of holes are created. So in intrinsic semiconductor, electron concentration is equal to hole concentration. So Fermi level is always lies at the middle of valency band and conduction band. So Fermi level means the highest energy level of the state is called as Fermi level. Extrinsic semiconductor. So extrinsic semiconductors are the impure form of semiconductors. So impure form of semiconductors means we are going to dope the other elements to the intrinsic semiconductors, pure form of the semiconductors. So then they will become into two types of semiconductors, P-type semiconductors and N-type semiconductors. So how P-type semiconductors are formed and how N-type semiconductors are formed means, see, here, if we can dope trivalent impurity, for example, here, indium is a trivalent impurity. So indium is a trivalent impurity. If you can dope this trivalent impurity to the germanium is the intrinsic semiconductor, pure form. So indium has 3 valency electrons. The 3 valency electrons of the indium are strongly bonded with the neighboring germanium. Germanium has 4 valence electrons, but if we can dope indium occupies the germanium place, and indium has 3 valence electrons. The 3 valence electrons are strongly bonded with the neighboring germanium, 3 atoms, and then here one hole is created. So that hole is called as acceptor. That hole is called as acceptor. So it can able to accept one electron. So if 2 indiums are added, 2 holes are created. 3 indiums are added, 3 holes are 3 holes. That 3 holes are called as acceptors. So like this, by doping the concentration of the trivalent impurity to the pure, that means the pure form of semiconductor, number of acceptors are created. So that number of acceptors are exist in the acceptor energy level. Number of acceptors are exist in the acceptor energy level. So see this in this diagram. So see here, by doping, for example, here boron is also a trivalent impurity. If we can dope here trivalent impurity boron to the 4th group element germanium, 3 valency electrons of the boron are strongly bonded with the germanium, and one hole is created. This is called as hole acceptor. So these acceptors are exist in this acceptor energy level, and bonded electrons are exist in this valency band at T is equal to 0 Kelvin. At T is equal to 0 Kelvin. If you can raise the temperature, first this acceptor first this valency band electrons are trying to jump to the acceptor energy level. Further raise the temperature, these acceptor electrons are also trying to jump to the conduction band. Then in acceptor energy level, holes are created, and in valency band also holes are created. So the whole concentration in valency band is more than electron concentration in conduction band. So in P-type semiconductor, P is greater than N. P means whole concentration, N means electron concentration. So whole number is greater than electron number in P-type semiconductor. So the Fermi level, so in intrinsic semiconductor, Fermi level lies at the middle. So in P-type semiconductor, Fermi level is trying to shift towards the valency band, So that is the variation of Fermi level with respect to the temperature. So like that in N-type semiconductor, how the N-type semiconductor is formed means, if we are going to dope pentavalent impurity, that is arsenic is the pentavalent impurity, 5th group element. So it has 5 valency electrons. If we can dope pentavalent impurity to the germanium, so arsenic has 5 valence electrons. The 4 valence electrons of the arsenic are strongly form a covalent bond with the neighboring germanium atoms, and one electron will become free. That electron is called as donor. This electron is called as donor. So if we can dope one arsenic, one donor is created. If we can dope 2 arsenic atoms, 2 donors are created. Like that, by doping the arsenic pentavalent impurity to the that is 4th group elements, pure form of the semiconductor, number of donors are created. Electron will become free. That free electron is called as donor, means that it is ready to donate one electron. So these donors are exist in the donor energy level, which is nearer to the conduction band. In P-type, acceptor energy level, which is nearer to the valency band. So all donors are exist in the donor energy level, and bonded electrons are exist in the valency band. So if you can raise the temperature, this bonded first these donor electrons are shifted to the conduction band at lower temperature. Donor electrons are shifted from donor energy level to conduction band at lower temperature. Further raise the temperature, this valency electrons are also trying to shift from valency band to conduction band. So in conduction band, electron concentration is increased. That means N is greater than P. N is greater than P in N-type semiconductor. So the number of electrons in the conduction band is greater than number of holes in the valency band in N-type semiconductor. So what about Fermi level? Fermi level is trying to shift towards conduction band in N-type semiconductor. But Fermi level is trying to shift towards valency band in P-type semiconductor. So that the variation of Fermi level is depends on the temperature and concentration of the charge carriers. So like this, a P-type and N-type semiconductors are formed and the variation of Fermi level is like this. So this is about intrinsic semiconductor and extrinsic semiconductor. Thank you.